We have some technical problems, so it's going to be another 5 minutes.
Hey, no projector. So I meant to do a live demo today, which is difficult unless y'all want to like huddle around behind me. But, oh yeah. Okay. Hi. All right, we'll do the best we can. Hi, I'm Jag. I'm the chief architect for Ansible engineering. I apologize. I had meant to do a live demonstration, which is difficult without a projector, but I will still kind of talk about Ansible Container, so if you're interested in going and checking it out on your own, we can do that. Things break. I don't like that things break, but my things break, your things break, all of our things eventually break. If you've worked in systems administration or support long enough, the first question you should always ask when something breaks is, what changed? What'd you change? You changed something, didn't you? Something changed. And so it turns out that most of the reasons why things break are because somebody changed something. And I can really only think of two ways to address that. One is don't change anything, ever. It's a great way to have reliable IT. It's a terrible way to run a business. You will go out of business very quickly if you don't evolve and adapt. So the other way that you can approach that is to manage change better. And there's a tool for that. It's called Ansible. Ansible is a fantastic way to manage the chaos, manage the change, manage transformations in your IT infrastructure. So great, good for us. Got that one solved. But things still break. And the other major reasons that things break is that we are not alone. My things would probably break a lot less if it weren't for all of you. If you didn't log on to my website, probably wouldn't break. If you didn't have to run any programs on my computers, probably wouldn't break. In fact, if I didn't run any programs on my computers, they probably wouldn't break. You know, if it was just one thing being done all at the same time, things would probably break a whole lot less. And so this is really why we're excited about containers. Containers are really cool because we can help manage the ways that things interact unexpectedly. You have unexpected resource conflicts. Two programs trying to write to the same space on the disk, two programs trying to talk to the same resource, cascading failures between different systems that are trying to talk to each other. You have security problems. You have things running as root that can do anything. You have users finding ways around the boundaries that you've set up. You've got bad actors outside interacting with network-connected systems and finding ways to use them in unexpected ways. And you've got resource hogging. People use more than they should. And so other people using resources means there's less available for you. Containers really help us solve all of these problems simultaneously. That's really why I'm excited about containers. The interesting thing when you look at containers or serverless even, the idea behind it is really this ideal of DevOps, that we can do things faster, we can do things better, we can do things more reliably, but we can do it together. In which case, the problem of other people kind of goes away. And when you look at it, there was actually a poll done by the new stack back in 2016 asking, what container orchestration technologies are you thinking about using? Bet everybody can guess number one. Nope. It's the one that won the war this last year, Kubernetes. Everybody's thinking about using Kubernetes. Kubernetes is the de facto champion of container orchestration. Can anyone guess the number two technology? Also not Docker. Ansible. It seems surprising, doesn't it? I mean, we don't really think of Ansible as a container-centric technology, but the reality when you look at it is that containers are never just containers. Even serverless, you still need a server. And you need that server to be connected, and you need that server to be maintained, and you need it to talk to other things. And the minute you start talking about how are we going to set these things up and manage these things so that they don't break, we start talking about Ansible. And so when we look at Ansible, there's even some container-specific parts to it. You know, it's a great way to define the way that a system should be laid out in sort of provisioning. But we've also got the ability to talk to container engines and platforms. We've got connection plugins where we can use the container engines themselves in order to talk to and make changes to containerized infrastructure. And so when we looked and saw that we had all these sort of primitives there in the Ansible ecosystem, we thought, what if we just built some glue and turned this into a tool where you could build, run, and deploy your containers using Ansible? And it was around the same time that I, for the first time in a few years, wrote a Dockerfile. I had used Docker for development environments for years and deployed to production. And I hated having that, I had a Dockerfile for my dev environments, but then I had my Ansible playbooks for how I was going to set everything up in EC2. And so I was writing Ansible playbooks for everything. And then suddenly I had to go back and write a Dockerfile, and it sucked. Because when you look at it, a Dockerfile is a shell script. I thought I was done with that. I didn't really want to write any more shell scripts. You have all the problems inherent in shell scripts in a Dockerfile. You have arcane single-letter command flags to all these command line utilities. You have these ugly, unmaintainable lines of code with the double ampersand and backslash at the end in order to make sure we don't add too many layers. And it was ugly, and it was hard to test, and it was hard to maintain as a group. It was hard to read and figure out what it was doing. But these are all things that Ansible's really good at. And so the other thing that we found out when we were talking to a lot of customers was that people are trying to make the leap into containers, but nobody is dropping everything they have now and picking up containers tomorrow. There's a curve. There's changing some things. There's these services are containerized, but these legacy things are still there. And so the fact that they were configuring and building everything else using Ansible, but then suddenly had to switch to this completely other format and set of tools, it was really frustrating. And so we got some pretty good resonance early on with Ansible Container. And the basic idea is this. You define the layers of your container images as Ansible roles, which, thanks to House, we now know everything about. But you can build your container images, and it does an orchestrated build where it applies those roles to a container base image and commits them. And then you can run those containers together, similar to the way that Docker Compose works. And you can deploy those containers. You can define the same application orchestration that you use to test them locally. You can use to generate an Ansible playbook to set up that same application in production Kubernetes or OpenShift. And the heart of Ansible Container is really this container called the conductor. The conductor container does all the heavy lifting. And it's got a couple of nice benefits to it. So it's got the Ansible runtime all baked in. You don't have to bring your own copy of Ansible. But if you're using Ansible to build other systems, you need SSH in those systems. You need Python in those systems. You need all your dependencies in those systems. And it kind of sucks for a containerized world. We want to build containers that are as small as possible so that we're as resource efficient as we can be. But we also want to build our containers in ways that have the smallest attack surface possible, because we want to keep them as safe as we can. So we don't want SSH in our containers, and we don't want to bloat our containers by having the entire Python stack if it's a Node.js container. It seems ridiculous. Well, so the conductor kind of solves these problems for us. So the conductor uses the underlying container engine that you are running in order to go back out and connect to those containers through that engine. So if you're doing your builds on Docker, then it uses the Docker engine to go back out and connect to the target containers in order to apply the Ansible playbook. So no SSH needed. But we can also use volumes. So the conductor containers, you have to specify your distribution. And so if you're building CentOS target containers, you need a CentOS conductor. If you're building Alpine target containers, you need an Alpine conductor. And what Ansible Container will do is it will take basically /user from the conductor and mount it into your target containers and use that for Python, for all of your other dependencies, for package management, libraries, all of that. So you get all the benefits of being able to use most of the Ansible modules without actually having to have a Python runtime on your target machines. And like I said, the really cool part, especially, is that if you're doing your local development, you're building your containers locally, and then you want to send it off to Kubernetes, to Google Compute, to OpenShift, you can do that using the exact same document saying how your application runs. So we don't have to have a separate Docker Compose file and a separate Kubernetes configuration. We can do it all at the same time. We're on the road to 1.0. We've got a fairly substantial user base and some really cool use cases that people are putting out. A couple of the Red Hat products have even tried to see how they could containerize their traditionally monolithic applications using Ansible Container. Mostly right now, before 1.0, we're looking to harden it. We got a bunch of, every time somebody submits a bug report, usually it's because they're using Ansible Container in a way that we hadn't predicted. And then we're really working on our documentation because we need a good, easy on-ramp to make sure that all the different layers of the container journey are clearly spelled out. But once we get to 1.0, we've got some other really cool ideas. So Tomasz Tomacek right here, one of our contributors, he is working on taking the OCI tools that Red Hat's been working on, so Builda, Cryo, Kpod, things like that, and implementing those, since Ansible Container, like Ansible, has pluggable backends. We can, instead of needing Docker on your desktop, you could build your containers using runc and Builda. You could deploy them to a locally running version of Cryo with Kpod instead of to Docker itself. So we'll finally really actually have a build system that has all the richness that's available in the Docker ecosystem while able to build your containers without actually having a Docker daemon anywhere in sight. It was, again, my intention to do a live demo, and I'd be more than happy to demonstrate it to anybody who finds a way to grab me. But otherwise, I'll be happy to take any questions, any ideas, any frustrations, or anything about the Ansible ecosystem in general. But thanks for sticking it out. I'm sorry about the projector. I presented in this room last year, and this seems to be an annual plague upon the conference. So anyway, but that's what I got. So anybody have any questions, concerns, things like that? Feel free to hit me up. It's a good question. Has anyone used Ansible Container? House, you don't count. Okay, a couple hands. How many of y'all are developing Docker locally and pushing to a remote Kubernetes? Just too much. How many of you are actually using Kubernetes in production? Okay, so what are y'all using to build your images right now? Just using Dockerfiles? Okay. Using, like, just building your own and pushing them into Kubernetes? Okay, cool. All right. Well, otherwise, enjoy the conference, and thank you for your attention. Cheers.
Thank you. Sorry about that. It was kind of unexpected. We will have 10 minutes break, and then we will continue with the next talk.
Just.
I already told that we are going to start in 10 minutes, so maybe part of the people are actually waiting.
I can tell them, or you can tell them.
Okay, sorry, there is one more change in plans. We will start as we initially thought we will start at 12, so we have 25 minutes break.
Yeah, the thing is that we don't want to abandon the schedule, so the next talk will be in 30 minutes. So if you want to get the coffee, and we'll start at noon with the next session.
I don't know if it can be done.
There's no we have one hour between these two. So at 2 p.m. and 3 p.m. there's 1 hour, but I don't think there's no official time for lunch. So I'm just asking.
Maybe I will run away.
Yeah, because everyone is at least anytime someone should be here. Yeah, exactly. It's okay. Yeah. My wallpaper.
It's better for you to
be here. Yeah, definitely. Yeah, this one I expect to know when, because I was thinking about getting some food.
So I will be here to start.
Yeah, right. Yeah, be here, but
genuinely.